Okay. So last time we have covered the first example of what we call the discrete probability distribution. That was binomial probability distribution. And before we can go to the second type of discrete probability distribution, I think I should finish the exercise questions on page 51. Okay, that will be exercise 2.2. Okay. I think I'll just go. I'll do the two exercises, and then we go for the second last part of binomial. That would be if the P of your probability of success is greater than 0.5. Okay. Exercise 2.2. A missile guidance system has 5 fail-safe components. The probability of each failing is 0.05. Find these probabilities and interpret your answer. Okay. Now, we know that when we say about binomial probability distribution, there will be how many criteria class that fulfilling the binomial probability distribution? Can someone tell me? Class, how many what we call criteria for binomial probability distribution? Class, when we say binomial, it means that 4 criterion. Okay, so that will be the first one would be what? An identical trial. Are you ready for your test and quiz 1? All these will be asked in your quiz 1. An identical trials. If you have only one trial with 2 outcomes, that would be what? That would be Bernoulli, right? But if we have n identical trials, okay, means that more than one trial, so it will definitely, if with the other 3 criteria, it will be binomial probability distribution. The second one would be, there will be 2 outcomes, okay, and that outcome is known as success or failure. Okay, and we know the probability of success is denoted as P, and probability of failure is 1 minus P, that is equal to 2. And the third one would be what? Independent. Yes, independent trial. Okay, independent trial, whereby the outcome of each trial would be, the success will be the same. Means that independent trial means that each of every trial is not affected, will not affect the other trial. And the last one would be probability of success is constant towards trial to trial, will be P. Okay, so constant means that the probability of success will always be the same for each and every trial that you have, for every n trial. Okay, now knowing that, okay, if you have this kind of questions, okay, since in your assessment there would be no clue whether the given question would be binomial, Poisson, or normal. Okay, so what can you do is, by evaluating the criteria of each of the distribution probability distribution types, you know that we are going to cover for discrete, we are going to cover binomial and Poisson. Okay, and for continuous, we are going to cover about normal. Okay, so on top of that, we are going to also discuss on how we can what we call approximate. Okay, approximate from binomial to Poisson, And there will be also approximation of binomial to binomial and Poisson to normal. Okay, so basic for binomial, Poisson, and normal. Of course, for normal, it will be continuous. And for discrete, you have only two, binomial and Poisson. Binomial, you will have four criteria. Poisson will be one criteria. You can say one criteria because it will be based on the time interval or interval given in your random variable. Now, back to the question. A missile guidance system has 5 fail-safe components. Okay, since we are discussing this under binomial, then you know this is binomial. Okay, and having said that, we have 4 criteria that fulfilling the binomial probability distribution. Now, the probability of each failing is 0.05. Find these probabilities and interpret your answer. Okay. From this question, of course, you are going to figure out what will be your n trials and what will be your probability of success. And definitely, when you know that you have to identify these two figures, then you will go back to your question. Which of the figures fulfill the probability and fulfilling the number of trials? So obviously you can see the probability is 0.05 and this is what we call the probability of success. Okay, or we call it as P. And what about your N? How many N involved in this question class? Look for numbers. And the only numbers that you have is this one, right? So this will definitely be your N. But of course, when you evaluate or you assess your equations in order to find out what will be the P, what will be the N, there will be few numbers sometimes involved in that particular equation. So you have to figure out which of the figure is referring to what. Then only you proceed with the equation. Okay? And in this case, what will be your X random variable defined as? Okay, what will be your random variable defined as? So the best clue to see is at your equation. Look at your equation. The probability of each failing is 0.05. Find this probability and interpret your answer. Okay. So if somehow my voice somewhere in the conversation, my voice is losing, so please tell me, because I'm using my mic right now. Okay, now what will be your X? So in this case, always referring to the number. What is the defined random variable for binomial and Poisson? It will always refer to the number. So it will be the number of what? The number of failing missile guidance system. Okay, and then since you have defined your X random variable, then you will have to write down what will be the distribution of your X random variable. So we know that X is following binomial with the parameter number of trial that will be 5 and probability of success is 0.05. So in this case, the probability of success is referring to the failure. So this is what I meant last time. The probability of success is defined based on your equations, and sometimes the success is referring to the failure. So this is one example of that particular failure. Now, find the probability exactly two will fail. Okay, so I have two what we call two types of solutions, because we have in your textbook we have using what we call Excel, and the other one is using the binomial table. Let's say we use the Excel. Okay, so in order to use your Excel, then I'll just choose for the second equation for the Excel. Okay, the first question will be using on the table because I need to save my time. Okay, now find the probability exactly two will fail. Okay, So we know that X is distributed binomial with the number of trial 5 and probability of success is 0.05. So the first question, probability of X exactly 2 will fail. Okay, exactly 2. We know that if we are using our table, okay, if we are using our table, we know that the notation is fulfilling this, okay? It would be less than or equal to the number of k that we are referring to, and this is our k. And what does this mean? This is defined as your p x less than or equal to 0. And the second one here is px less than or equal to 1. And you can refer to the last one here is what we call px less than or equal to the number of whole number of trials, that would be 2. Okay, that's why we have 1, which means we have the summation of all the what we call x is equal to 0, x is equal to 1, x is equal to 2. So we have the 3 components. So for exactly x is equal to 2, we look for the number of trials, and it's referring to the number of trials. We look for number 5, and we look for the probability of success 0.05. And definitely we know that we have to refer to this particular box only for the number of the probability value. Now, we know that from our last discussion, in order to find exactly x equal to 2, okay, so we have to take all the px less than or equal to 2, which is this whole area, and we know that we have 1 here, okay, so we have 1 here, so we know that we have to deduct with the probability of less than px less than or equal to 1. Then only we can get px exactly equal to 2. So in this case, it will be px less than or equal to 2 minus px less than or equal to 1. So look from your table. For 5 numbers of trials, okay, we look for 2. Exactly 2, it will be given by 0.9988. Deduct with less than or equal to 1, that will be 0.9774. Okay, what is the given? Can someone calculate for me? 0.9988 minus 0.9774. What is the value? What is the value? Someone please calculate for me. 0.021.
0.0.
Now, 214, okay? Now, the question asks you to find the probability and interpret your answer. So you have to interpret. How do we interpret our probability value? Okay, so in this case, we can transform this into 100% because we are talking about one probability, which means 100% probability. So if you got 0.0214, so you multiply by 100, you will get 2.14%. So you are going to interpret this 2.14% in terms of chance or in terms of likely or unlikely. So if let's say I use the word chance, how do I interpret this? So you can say there is 2.14%, or you can say 2% chance that exactly 2 missile guidance systems will fail. So this is one way of how you can interpret your answer. So the other way on how to interpret would be, since the value is too small and we know that our probability is from 0 until 1, and we are talking about 2.14%. So if let's say this is 0.5, So we are talking about 0.0214, almost or near to 0. So the other way of how you can interpret this probability value is by saying, okay, so this 0.01214 is somewhere here, okay. So you can say it is unlikely that exactly two missile gardens will system will fail. Okay, so this is how you can what we call interpret your answer. Okay, any question here, class? Any question here? If no question, then move to the second question. More than two will fail. Okay, more than two will fail. Okay, I'll just continue my answer somewhere here, right? Okay, number two, probability of more than 2, x greater than 2. So how do we interpret in terms of the probability value? What minus what? If you can imagine, if we are talking about px from 0 until 5 number of trials, we are talking about 1, 2, 3, 4. Okay, so more than 2, since 2 is not included, so we know that exactly 3 and above is what we are talking about. Okay, now knowing that the whole probability is 1, okay, and to fulfill your table, that will be according to this particular symbol. So we will have 1 minus px. Since 3 is included, then we are going to talk about this particular region in terms of less than 3. So it will include what we call px less than or equal to 2. So in this case, 1 minus px less than or equal to 2, less than or equal to 2 is 0.9988. Okay, 0.9988. So 1 minus 0.9988 is what, class? 0.0012, right? Correct, class?
Yes,
You all,
doctor.
okay. Just say yes quickly. Okay, we are saving our time then. Okay, now this will be equivalent to what? 0.12%, right? So how do you interpret? So there is, okay, you can say there is 0. To be exact, there is 0.12% or nearly zero chance. Okay, you can either write this one or write this one, either one. Okay, there is 0.12% chance that more than two missile guidance will fail. Okay, so if you can observe, if exactly 2, the probability is 2.14%. If we find the probability more than 2, the probability getting smaller, that is 0.12%. Now, question number 3. Okay, all will fail. So if you say all, so we are referring to the whole missile guidance system, that is 5. So exactly 5 will fail. Okay, so how do we find the probability of exactly 5? Then we know it is x less than or equal to 5 minus px less than or equal to 4. Okay, look from your table. So if you go back to your what we call binomial table for 5 number of trials, the table will stop until 4. Okay, so where is the 5th trial? Is actually there. Since you from beginning from the 2nd trial, 3rd trial, 4th trial, the probability is exactly 1, means that the 5th one is also 1.00. So in this case, less than or equal to 5 is actually 1.000 minus x less than or equal to 4, that will be 1.000. So you will get 0. Okay, so how do you interpret then? Okay, there is 0%, there is 0% chance that all missile guidance will fail. Okay, so it is unlikely, it is impossible that all missile guidance will fail. So you can say that way also. Okay, and the last one, compare the answer for part 1, 2, and 3 and explain this result, why these results are reasonable. So how can you say about the result first? When you have exactly 2.14% chance of exactly 2 missile guidance will fail. When you talk about probability more than 2, the probability value even getting smaller, nearly 0 or 0.12% chance. And if you talk about exactly 5, so it is impossible that all missile guidance will fail. So how do you explain that all these are reasonable? Class. Can someone give me any reasonable answer? Okay. The first one you can comment. Okay, for number 4. First, comment on the probability value. Okay. As the number of system failing, the probability approaching 0. And the second one is what? Okay. The second one you can say about will be based on the missile guidance system. We are talking about missile guidance system, and we are talking about a weapon that will be used, okay, for military purposes. And of course, in the military purposes, we are concerning with the safety, and we are going to make sure that whatever trial we do, it will be the best possible in terms of what we call payload. Okay, so in this case, talking about failure, definitely the probability of failure would be very, very small. So it is reasonable when we say the more failure it happens, the less chance it will be, okay, in terms of the what we call safety, or in terms of the what we call context of missile guidance. Okay, I'm not going to write for you. Okay, since you are not responding to my questions. Okay, so any questions so far, class? Okay, now if we are using our what we call our Excel, okay, now if we are using our Excel, how can we use our Excel? So we know that we have what we call exact probability and cumulative probability. So the first one that I highlight with yellow is what we call individual or not cumulative. Means that this probability is referring to exact what we call, this is probability of x exactly to equal to 0. This one is px exactly equal to 1. and followed until the last one. This is probability of x exactly equal to 5. If we have cumulative, okay, for example, as this one, okay, so in this one is representing as px less than or equal to 0. This one follow our binomial table. This one is px less than or equal to 1. And this one is px exact less than or equal to 1. If you can see, the value is 1, okay, means that you sum up all the values, the previous value, to get 1. Okay, so how do I get this? Okay, how do I get this? Now, this one is obtained by, okay, by what we call a binomial function in your Excel. Okay, if let's say I redo again this part. Okay, so let's say what you can do is just start doing by using your equal sign. Okay, once you got your equal sign, then type binom. And somewhere in your Excel sheet, it will show us but few options of binomial. And what you will have to choose is binom.list. Okay, and if you double click that binom.list, what you will have is the first one is the number of file. Okay, sorry, and the number is referring to the x value here. Okay, then you have to include your number of trial, the probability of success, and the last one is your what we call option, whether you want to have the cumulative or not the cumulative one. So if let's say we are doing the individual probability value, so identify your first x that will be equal to 0, double click your x is equal to 0, then put comma, then insert your number of trial, that would be 5, then comma, put your probability of success, that would be 0.05, then comma, and then you have your cumulative. So in order for you to have your what we call non-cumulative, then you will have to put 4. Okay, then put your close bracket, then you will push the button enter. Then what you can do is drag to the until your fifth number of trial. Okay, so if I delete, then I drag until number 5, then you will get the probability value. So that's why if you look at the cumulative and non-cumulative, okay, so the first one will always be the same. The second one for non-cumulative will be your individual probability, but for your cumulative, it will be cumulative of this one plus this one. That's why you get 0.9774. So this is how you can find based on your binomial in your Excel. So in your case, if you are using this individual probability, what happens if you wish to what we call solve for the problem? Okay, if you are solving for number 1, for example, okay, exactly 2, okay, px exactly 2, definitely you will get your answer from your table of Excel. Px is equal to 2, definitely is given by 0.02143. What if you need to find for more than 2? Px, okay? So let's say I do it in somewhere over here. Px more than 2. More than 2. More than 2. So that will be what? Px equal to 3 plus Px x is equal to 4 plus px equal to 5. Then you add on. So 0.0 equal to 3 is 0.00113 plus equal to 4 is 0.00003 plus 0.00000. So if you add all this, you will get what? Plus 0.00113 plus 0.00003. Okay, so you will get 0.00116 minus 3. Okay, what is your value here? Okay, almost the same. Okay, almost the same as what you get over here. Okay, so that's how if you want to use your Excel table. But it turned out to me it is simpler if you use your cumulative binomial table. Okay, any question before we move to the second question? Any questions?
Okay.
No. Okay. Now the second question. The reason why I do the exercise to you is just to show you how you can find the probability and how you can interpret your probability value that you got. Okay, because afterward I want you to start doing all the tutorial question regarding the binomial Poisson. Okay, that will be for your preparation for test 1 and quiz 1. Okay, now a student takes 20 questions, true or false exam, and guesses on each question. Find the probability of passing. If the lowest passing rate is 15 correct out of 20, would you consider this event likely or unlikely to occur? Explain your answer. Okay, so how are you going to tackle that question? Class? Okay, so how do we define our x? What be our x? As I said, how do I know my x? Look at your questions. Find the probability of passing. We are talking about passing. Passing what? Passing the exam. Okay. So, but what are the contexts that we are talking about? Because we know that x will always be the number. So what will be the number? The number of what? So the
Correct
number of what?
answers.
Yes, the number of correct answers. Okay, and we know that definitely this is following binomial, and of course during your exam you have to evaluate all the 4 criteria. So binomial, how many trials do we have in this case? How many questions do we have? 20 questions, right? Yes, 20. And the probability of success is what? How do we know? Because there is no probability value given in your question. How do we know that what will be our probability of success then?
0.5.
Why 0.5?
There's only two possible answers.
Yes, because since we have only true or false, then it will be equally likely to have true or equally likely to have false. So since we have that condition, definitely the probability of success is 0.5. Okay, and of course because we have this right here. Okay, now let's say we proceed to the question. Find the probability of passing. What is the passing mark? 15 correct out of 20. Then how should we form our equation then? X, we know it will be 15. Should it be greater than, less than, greater than or equal to, less than or equal to, or is it equal to? How do we know? Which sign is it? Is it equal to, greater than or equal to, less than or equal to, greater than or less than.
Greater than equal.
Why greater than and equal to?
Because it's the lowest passing grade.
Okay, it is the lowest passing grade. But when we say passing grade, so the student should get correct. It's either he or she correct 15, 16, 18, 19, or 20. So it will be greater than or equal to. Right. Okay. Lowest passing grade is 15. Means that it should get greater than or equal to or greater than only.
Including 15, so must be greater than and equals to 15.
Okay. Okay. So greater than and equal to. Okay. So if we know that 15 is the passing mark, so greater than or equal to means that it will be 1 minus px less than or equal to 14, right? So if you refer to your table, for n number of trial 20, so for 3 probability of value 0.5, we wish to get 15. Okay, we are talking about 14, right? So 1 minus 14, so it will be 14, you will have 0.9793. 0.9793. So you will get what? 0.0
0.0207.
207. Okay, or we can say multiply by 100, you will get 2. You will get 2.07%. Somehow I want to use my calculator. I'm afraid to get it wrong. Okay, so what will be the interpretation of 2.07%? Okay, so we can say there is 2.07% chance that more that the students, okay, that the student, because we are talking about the student, that the student find the probability if the lowest possible. Okay, a student takes, okay, there is 2.07% chance that the student will pass the exam. Okay, or if you go based on the likely or unlikely, it is unlikely that the student will pass the exam. Okay, so that's how you answer based on the given condition, likely or unlikely. Explain your answer. Why? Because the probability is too small. Okay, so that would be your reason. So this is the first that you need to answer. This is your interpretation, and this is your what will be your explanation for your answer. Now,
Betul.
yes.
Kalau untuk kita explain answer tu, lebih baik kita masukkan percentage macam 2.70 ataupun kita just terangkan je macam it is unlikely that the student will pass the exam.
Okay. If your question is about likely or unlikely, it would be okay. Okay, not to use the probability. Okay, But if you're talking about chance, okay, better put the probability value because you're talking about chance. So how many percent chance? So that reflect your probability value. Because likely, unlikely, we know. Unlikely is referring to the value approaching 0. Likely is approaching 1 probability. Okay. So any other question?
Doctor,
If yes.
so if explaining, can we just say the probability is small because the passing rate is too high?
Can, but you have to go based on your what we call on your evidence. So what is your evidence? Uh, you can see the passing rate is too high, but usually your answer will be based on your calculation that you have made before. So that's why the question that is being asked is for you to refer to your previous calculation that you have made. Okay, that's why that is the purpose of the question is being asked to you. Okay, there will be usually the question that is being asked and reflecting about your interpretation. It will be based on what have you what you have what you calculate previously. Okay, so there would be less possibility that you can use the what we call the surrounding as your reason to your whatever question being asked. Okay. Okay. Any more question before I move to the one that I need to cover? Okay. If no question now, turn to page to your textbook on page 52. Okay. After exercise 2.2, there is a subtopic called calculation using cumulative binomial probability distribution table for p greater than 0.5. Now, can you turn to your last page of your binomial table? Can you please turn to your last page of your binomial table? That will be on page okay, that will be on page 205. 205. Now, can someone tell me what can you observe in terms of the probability of success on page 205? 205. Can someone comment on the probability value? What is the number of trial? The largest number of trial in your binomial table is 30, right? Your n is 30, right?
Yes.
Right? Okay. Now, what is the largest probability of success given in that table?
0.5.
0.5, right? Okay. Now, you obviously can see that we have limitation for our binomial. There is binomial table that complete for each and every number of trial, even you have until hundreds and thousands of binomial trial. But okay, your P will always maximum until 0.5. Now, there are sometimes in the situation of your equations, the probability of success would be greater than 0.5. And how do we tackle this kind of situation? Okay, this is what I'm going to explain to you, and I'm not going to repeat whatever material that has been discussed in your textbook on page 52, but I'm just going to summarize them in terms of how you can solve them easily. Okay, so what if you find out that your questions, the probability of success given in your question is greater than 0.5. For example, if we refer to your example 2.10, okay? If you can see from example 2.10, okay, according to the tables provided by the US National Center for Health Statistics in Vital Statistics of the United States, there is about 80% chance that a person aged 20 will be alive at age 65. Suppose 10 people at age 20 are selected at random. Let us attempt to use the cumulative binomial distribution table to find the probability that at least 8 people will be alive at age 65. Okay, now find the probability that at least 8 people will be alive at age 65. So, in this case, as usual, you will have to define what will be the random variable involved. So, we know that it will always equal to the number. Number of what? To the number of person age 20 who will be alive at age 65. So that will be your X. Okay. Now, and we know in this case, how do we know that this is a binomial probability distribution? The simplest way to find out it is a binomial, not Poisson, because Poisson will always be one parameter, but binomial there will be two parameters: the number of success, the probability of success, and the number of trial. So in this case, suppose 10 people at age 20. So you know definitely this is the number of trial that you have. So X following binomial, the number of trial is 10, okay, and the probability of success is 0.8. So that's how you write down your X, what we call distribution of your X. Now, how are we going to solve this? Okay. Having said that, we know that if, let's say, from 0 trial until the 10th trial, the whole probability is 1, right? And if we are talking about 0.8, okay, 0.8, let's say the 0.8 somewhere is over here, okay, we can find what will be the rest of the probability out of the 1 probability value. So, using that particular, what we call a concept, we are going to transform your X with probability greater than 0.5. And how do we transform? Okay, so it will be, let's say you can use your X or you can use a new variable. Let's say following the textbook, we create a new variable Y. Okay, now Y still following binomial. Okay, and the number of trial will always be the same 10, but the probability of success is going to the reverse. What will be the 1 minus? That will be a Q, or 0.2%. That will be the first transformation. And of course, when you transform that into Y, then what will be your Y? So Y will be the number of people at age 20 who will not be alive. Not alive means that the reverse of this one will be alive, will not be alive, not alive at age 65. Okay, as simple as that. Now, the second transformation is from your equation given to you. Now, the given equation is, suppose 10 people at age 20, okay, find the probability at least 8 people will be alive, at least. So, Px greater than or equal to 8. Right, at least 8 will be alive. Now, since we transform the distribution, okay, we also need to transform your problem. And this will be, okay, the same concept. Out of 10 that we are talking about, we are looking for at least 8 people. So we are going to transform this into y less than or equal to 10 minus 8. Okay, so it will be y less than or equal to 2. Okay, so in this case, we will have that directly from your table. Okay, so from your table, if you look for, can someone give me the value? What is the value for what we call 10 number of trials and number of success is 0.2. What is the probability? Less than or equal to 2? 0. What? Someone please.
0.6778.
Okay, thank you. Now, this is the probability value. Okay, so if you wish to find what is the value here, you can always use the formula. Check, double check. If, let's say, greater than or equal to 8, so it would be, you can use your formula, find the px equal to 8 plus px equal to 9 plus px equal to 10. Definitely the summation will get this value. Okay, so in this case, what will be your interpretation? Okay, so there is, if you can approximate the probability into, there is 68% chance, you can also do the approximation for the probability value. So there is 68% chance that at least 8 people will be alive at age 65. Okay, so that will be your answer or your interpretation for Py greater or equal to 8. So when you interpret that, so the way you interpret, you will be based on your x that we have earlier on, not in terms of 1. Okay, so remember that. Okay, so remember that. Now, finish with the example. Now, let us look at the exercise. Now, exercise 2.3 on page, okay, on page 54. Okay, Newsweek reported that 60% of young children have blood levels that could impair their neurological development. Assuming that a class in a school is a random sample from the population of all children at risk, the probability at least 5 children out of 10 in a sample taken from a school may have a blood level that may affect development. Okay, so how are we going to solve this? Okay, now first identify what will be your x. Here. It's the number of what? The number of what? Where is the equation? The probability at least 5 children of, okay, it's a bit long, okay, until, so the number of what? The number of children, the number of children who have blood level that may impair development. Okay, and x is distributed following binomial by how many number of trial class? How many number of trial? 5 children out of 10. So how many trials do we have then?
10.
And
10. Thank you. And the probability of success is 0.6. Okay? Okay, thank you. So you need to find the probability at least. So x at least is greater or equal to 5. Now we need to transform that. Transform into your, let's say we don't have to, what we call, redefine your x. Just transform the, what we call your distribution of y will be following binomial with 10 number of trial and probability of success is 0.4. Okay, 1 minus 0.6 is 0.4. So 1 minus 0.6, okay, so you get 0.4. And in your equation become ty less than or equal to 10 minus 5, you will get 1. Okay, so definitely straight away from your table of binomial, can someone please check for 10 number of trials with probability of success 0.4, can you tell me what is the probability value for less than or equal to 5?
0.3770.
Are you sure?
Salah
Salah. Cuba tengok lagi sekali betul-betul. 10 number of trial, probability of success 0.4.
0.6331.
Huh?
Betul tak?
Are you sure?
0.838.
Salah lagi.
I think it's the one row below 8338.
8.
Okay, thank you.
Okay, thank you. Thank you for trying. Okay, so 8, 3, 3, 8. So you can say there is 83% chance that at least 5 children, then you continue, and 5 children who have blood level that may impact their development. So that would be your answer. Okay, what about in a survey, 55% adults said that they have never heard about the IoT. If 20 Malaysian adults are selected at random, find and interpret the probability that less than 12 will say they have never heard about IoT. So let's say we answer this. Okay, what will be X? X is the number of what? The number of
Malaysian adult.
yes, Malaysian adult who have never heard about IoT. And X is distributed following binomial with how many number of trial? 20 or 12?
20.
20. And probability of success is 0.55. So what will be your equation? Find less than 12. X less than 12. So transform that into the reverse of your X. So it will be Y following binomial 20, 0.45, right? And this becomes P Y greater than 20 minus 12, you get 8. Right? Okay? So you get 8. Can you find the answer for this one? So this is what? Equal to what? How to get the answer? Y greater than 8 is equal to what? 1 minus Px less than or equal to greater than 8. Is 8 included? Greater than 8. 7,
No.
No.
8.
No, no.
So greater than 8, but 8 is not included. So 9. We begin with 9. So x less than or equal to 8. So can someone check from your table for n 20 p 0.45? What is x less than y less than or equal to 8? Zero point what? Zero point
0.4143.
4143. 1 minus 0.4143. 0.5 857. Okay, so you can interpret. So this becomes 58.57%, or you can approximate it into 59% chance. Okay, so there will be 59% chance that less than 12 will say they have never heard about IoT. Okay, any questions before we move to Poisson class?
No, Doctor.
Okay, no questions. Okay, before we move to Poisson, I believe you can see from your textbook on page 53. Okay, if you are interested on the details of how we solve for probability of success 0.5 and greater, so please read on page 52 until 53. Okay, but there is a section on the effect of n and p on the shape of the binomial probability distribution. So this particular what we call understanding will be the one that will be used for the approximation later on. Okay, now what is the difference? What are the things that you need to understand from these 6 figures actually? Okay, now from the first line here, okay, from the first line here, what can you observe is that, okay, look at the number of trials. You have the number of trials constant. Okay, n is equal to 10. Okay, what happens is that the probability of success, P, the change in P, that is from 0.2 to 0.5 to 0.8. Okay, what happens is n is constant. Okay, but your probability of success become larger. Okay, become larger. What happens is that from right skewed, it becomes symmetric and it becomes left skewed. So this is what happens if you play around with the probability of success. Okay, but if you have equally likely probability of success, it will be somewhat symmetric. Look for the second line of the 3 figures. Now, what happens is that the number of trials change in the number of trials from 10 to 30 to 70, and probability of success constant 0.2. Okay, what happens is that if you change the number of trials, okay, what happens, the more or the larger the number of trials, the symmetric it will be. The larger the number of trials, the symmetric your distribution will be. Okay, see how does one parameter affect the whole what we call distribution of your random variable that you are testing. So we are going to see this in the approximation topic later on. Now, let us move to the second part, that will be Poisson probability distribution. And we know that under probability distribution, we have two, discrete and continuous. So we have done our binomial part. Okay. Now we look at the Poisson. What is Poisson is all about? And then definitely afterwards we are going to see how the Poisson approximation of the binomial can be done. Okay. So we move to the continuous probability distribution. Now, in reverse to binomial probability distribution, for binomial probability distribution, we have 4 criteria. N number of trials to probability of success constant from trial to trial, and we have probability of failure is equal to Q, probability of success is equal to P, we have N independent trials, and finally, we have constant probability of success. Okay, now, what about Poisson? Okay, a Poisson process has the following characteristics. Okay, we cannot say, okay, Poisson got 3 criteria, 2 criteria, no. There will be exactly 1 criteria that fit your Poisson probability distribution. Now, what is the 1 criteria that you need to know? The experiment consists of counting the number still plus for binomial. Okay, X is the number of what? X following Poisson also referring to the number of what? But what is the difference between binomial and Poisson? The occurrences of an event over some interval. So this is the keyword, some interval. What kind of interval? For example, time, area, volume, distance, or any other types of measurement. Any types of measurement, but the X random variable is discrete or exact value. So the one defined for your Poisson will be the number of blah 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 given in the interval. So what interval? So definitely you will have to specify based on your given situation. So this will be the rest of the things that is differ from your binomial. Okay. Now, the number of occurrences in one interval must be independent of other interval. No limits of the number of occurrences means that you can have as bigger number as your n, or the number of occurrences. It depends based on the parameter that you have. Probability of events occurring in the same is the same for each interval. Okay, means that the same as what we have in binomial, but the rest of the criteria is are somewhat not highlighted. But the one that will be highlighted is the number 1 that will be given in the interval. Okay, average number of occurrences in interval is none. Let us see what does it mean later on. What are the example of Poisson actually? Okay, for example, the number of car accident during a month. How many car accident? 2, 3, 50, 200, 50, 59. So it gives in an exact value. The number of major defect in a particular 3 months. So the interval given in a month. Second, given in 3 miles highway. That is the interval. Okay. So major defect. How many defects? You can count them. 2 defects, 3 defects, 4 defects, 5 defects, so on and so forth. Number of website visited in 30 seconds. If you're talking about Unimed website, you are going to measure how many visitors visit in 30 seconds. So you can count them. Okay. The same, the number of patients at Unimed clinic between 9 until 12 p.m. So you can count the number of patients who came in. And last one, number of plant growing per acre. So of course you can still what we call count them. Okay. Now these are what we call Poisson probability distribution. Now, if we have X following binomial with parameter, we know parameter that we are talking about is the number of trials and probability of success P. And we know to find the probability of X equal to some value of x is ncx p to the power of x q to the power of x, okay, where x be from 0 until n. What about Poisson? Or before that, expectation of x, that would be the mean, is np. Variance of x, that would be sigma squared, is given by npq. What about standard deviation? Standard deviation of x is sigma or square root of np. What about Poisson? Okay, Poisson, the parameter is E naught lambda. Okay, this is what we call lambda. Okay, the only one parameter given in your equation is referring to the lambda. How do we find exact probability following Poisson? Px equal to some value of x is equal to exponent to the power of lambda, lambda to the power of x divided by x factorial, where x beginning from 0, 1 until n value. Okay? The simplest is Poisson. What is your mean, variance, standard deviation? Mean expectation of x, which is mean, is equal to lambda. Variance of x, which is sigma squared, is equal to lambda. What is your standard deviation? Standard deviation of x is sigma, that is square root of lambda. Okay, as simple as that. But the rest of the concept in finding the probability value are following what we have done in Poisson. Okay, now let us look at the first question. Suppose that the average number of cars arriving in a 15-minute period is 10 cars. Find the probability that exactly 5 arrivals in 15 minutes. Before we begin with the solution process, as usual, find out what is your random variable x. X in this case is what? 11. So x in this case is the number of cars arriving. Okay, 15 minutes. So the interval is defined in your random variable. So don't left out the interval given in your equation. Now x following Poisson, the lambda is equal to 10.
10.
Okay, 10. Yeah. Okay. So find the probability that exactly 5 arrivals in 15 minutes. Now, the most thing that you need to watch out when you have your Poisson equations, the given interval in your equation sometimes is not the interval being asked in your equation. For example, in this equation, the 15 minutes time is the same. Sometimes when you have equation, the given condition in your defined x is within 1 hour, but then your equation will be given in terms of minutes. So that is where you have to be careful. Okay, so in this case, since we are using the same interval, then it will be okay. Now, exactly 5, so Px exactly 5, then you can use your formula. That will be e to the power of lambda, that will be minus 10, lambda, that will be 10 to the power of 5 divided by 5 factorial. Right. Okay. So you can calculate. If you calculate, let's say you can follow the book, you will get 0.0378. Okay. If you turn to page for Poisson, okay, so if you look at the Poisson probability distribution, Okay, you have Poisson from page 206. Okay, so what will you have in your Poisson table? The same symbol for cumulative that would be less than or equal to. Okay, they are using the same exact probability function. And then you will have your x that would be referring to the first column here. That will be all your x. And you have your lambda that will be in the first row here. That will be all your lambda. So go back to your lambda, which to your referred lambda. So in this case, 10. Okay, now let's say we use our concept probability. In order to find the probability of x is equal to 5, we know we can use px less than or equal to 5 minus px less than or equal to 4. So for less than or equal to 5, so you will have 0.0671 minus less than or equal to 4 is 0.0293. Okay, so if you deduct, it will get the same 0.0378. So how many percent chance for this particular question? There is 3.7% chance, or you can say 4% chance that exactly 5 cars arrive in 15 minutes. Okay, there is 4% chance that actually 5 cars arrive in 15 minutes. Okay, now using Excel, I just leave out the using Excel. Okay, now let's say I change. Okay, I change into, never mind lah. Change the interval for the second question. Let's say we go to the exercise on page 56. Okay. One phone calls arrive at the rate of 48 per hour at the reservation desk for regional airways. Find the probability of receiving 3 calls in 5 minutes. This is what I said just now. The rate given in your interval is 1 hour, but the rate given in your equation is within 5 minutes. So this is what you need to be very careful in terms of solving the probability value. So let's look at how we can solve this. Okay, so phone calls arrive at a rate of 48 per hour. So it means that in 60 minutes. Okay, so x in this case is equal to the number of what? To the number of phone calls. Okay, phone calls. The number of phone calls in an hour. Right. So x is distributed following Poisson with lambda 48. So this is for 60 minutes. So since the question asks for you for 5 minutes, so that in that case you have to transform your x following Poisson 48 into 5-minute interval. So how do we change the interval? So this is how we transform that. So in 60 minutes, okay, so 60 minutes, you will get 48 calls. Okay. What about in 5 minutes then? So it will be 48 over 60 times 5. Okay. So 48 calls, 60 minutes, 60 minutes. So you will get how many calls? 1, 12, 4, right? 4, 4. So, x following Poisson equal to 4. This will be 5 minutes. Okay, any question here, class? Any question here?
No, doctor.
Okay. Then, proceed answering the questions. The first question, find the probability of receiving 3 calls. X equal to 3. It seems very simple since I'm doing it for you. But when it comes to your assessment or test or quiz, sometimes students got confused how to transform in this what we call question into this particular form. So please look at your question very carefully. Okay? So exactly 3 calls means that px less than or equal to 3 minus px less than or equal to 2. So look for lambda equal to 4 and your x is 3. So you will have 0.4335 minus 2. So 0.2381. So you will get what? 0.1954. Okay. So this is your probability if exactly 3 calls received in within 5 minutes. So how do you interpret? So this will be 19.54%. So there is 20% chance that 3 calls will be received in 5 minutes. Okay? Easy, right, class? Seems easy lah. Since we are doing it for you. So find probability exactly 10 calls in 15 minutes. Now you have to transform your interval into 15 minutes. So if I have in 5 minutes it's 4, then in 15 minutes I need to multiply by 3. So x will be following Poisson. 4 by 3 you will get 12. Okay. So for x following Poisson, lambda equal to 12, find the probability exactly 10. So px less than or equal to 10 minus px less than or equal to 9. So what is the value for 12? So for 12, 10 and 9. So 3472, 0.3472 minus 2.2424. 0.2424. So what is the value you got here? 0.1048. So almost 10.48% or 11% or 10%. Less than 5. So interpret on your own. Okay? Any question here, class? Any question?
No.
Okay, no question. Now, last part before we stop. Okay, before we stop. An average of 15 aircraft accidents occur each year. They look at the sign in your question. Poisson question always be the simplest question, but everything is there. Okay, find the mean number, variance, and standard deviation of aircraft per month. See, each year per month. Okay, so that would be your hint. The time interval given in your question, it will be in terms of year. But in your question, it will become month. Okay, what is your X here? The number of what? Plus the number of?
Aircraft accident in a year.
Yes. Aircraft accident in a year. And X distributed following Poisson with lambda equal to 15. It means that 15 for 1 year. Now, since you are going to look for 1 month, now, as I said just now, for 1 year is equal to 12 months, right? 1 year equal to 12 months. Okay, so 12 months, you will get 15 accidents. Okay, what about in 1 month? So 15 divided by 12 multiplied by 1, right? For 1 month. Okay, so you will get what here? 15 over 12. Or we can say it is equal to 15 over 12.
1.25.
1.25. Now,
5.
this is the trickiest part, because your lambda is using 1 decimal point. Now, when you have 2 decimal point here, if you took the approximation, it will be 1.3. But if you are using 1.3, it will be, your answer would be different. Now, I'm teaching you on how to find exactly by using your table, and you still got your exact value of your probability. Now, let's move to the questions. Find the mean, variance, and standard deviation. So that will be easy. Mean is equal to 15. Oh, sorry. You are referring to months. Okay. So 1 month. Then, okay, X following Poisson 1.25. This is for 1 month. Okay. So expectation of X or mean is equal to 1.25. Sigma square is equal to 1.25. Sigma is 12 of 1.25. That is equal to 1.118. Okay, done. Now, second question. Find the probability of no accident. Px is equal to 0 during a month. So we are using 1 month interval. Now, x is equal to 0 means that it is Px less than or equal to 0. So in this case, okay, see the answer is 0.2865. If I'm using my 1.3, my answer is 0.2725. Okay, so how I am going to find for exactly 1.25 of my lambda? So I will just use my table. So I use pen, green pen. Okay, so I know that 1.25 is in between this. Okay, so 1.25 is between this. Means that I need to find what is the interval from here to here. So 1.2, 1.25, 1.3. So 1.2, I have 0.3012. For 1.3, 0.2725. So I need to find what is the interval here. So I deduct 0.3012 minus 0.2725. I will get 0.3012 minus 0.2725. I will get 0.0287. So this is the range. I need to divide by 2. Okay, half. So I need to divide by 2 because I need to find this is the value here, the middle value here, which is 1.25. So divide by 2. So I will get 0.01435. So since the number is decreasing, so I need to deduct 0.3012 for this one. So 1.25, I will get 0.3012 minus 0.01435. That will be 0.28685. Okay, then I know for exactly less than or equal to, for probability of x less than or equal to 0, exactly for 1.25, it will be 0.2868. Okay, or 69. A bit different from your answer here, but this is exactly the correct one compared to approaching 1.2. Okay, the second question, the third question is find the probability exactly one accident x is equal to 1 during a month. So px less than or equal to 1 minus px less than or equal to 0. Okay, so for 1, okay, so again for 1, if you do the same concept of what I have just done, okay, 0.6628 minus 0.6268 divide by 2, okay, you will get 0.019. So minus 0.66626, you will get 0.6447 minus less than or equal to 0 is 0.2868. Okay, so you will get 0.6447 minus 0.2868. You will get 0.3579. Okay, almost the same as the answer here. If you are using this 1.3, okay, it will be if you are using 1.3, it would be 0.8571 minus 0.6268. So this will be what? 0.8571 minus 0.6268. This will be 0.2303, which is further away from the answer. Okay? Any question here so far, class? Any question? So how you interpret? Yes.
We can add those two and then divide by 2 and so get the same answer.
Can also add the two. If you add, let's say we take question 1. You mean you add, you add. What you add is 0.3012 add with 0.2725,
Yeah, 1.2 and 1.32, 0.3012 plus 0.27.
Okay, 0.3012 plus 0.2725 divide by 2. Can? It's much easier. Also can. Okay, so means that I use the other pen. So the easiest also is adding 0.3012 plus 0.2725. Okay, and then you divide by 2, you will get 0.28681. I did not think of that. It is much easier. Also the same. Okay, thank you for the suggestion, which is much simpler. Okay, the same if you have 1.3, then you have to do. Okay, I don't want to further discuss that. I'm afraid it will be confusing later on. Okay, so I think you have got the what we call the idea of how you can do that. So for question 4, can you please try, and you supposed to be, this one is supposed to be correct lah. Okay, so use the same concept as I explained to you just now, and you can find the exact value for your probability of that you are looking for. Now, okay, I think I'll just stop my recording here because I need to